Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Patuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area Planet Earth and Beyond. The topic is Beyond the Solar System, and then the subtopic, which is our main area of focus, is our nearest star. Now let's look at the lesson objectives. At the end of the lesson, you should be able to name the Earth's nearest star, explain the role of our nearest star, and name the star called Alpha Centauri as the nearest easily visible star to the Sun, and then write the large numbers associated with space distances. All this can be found in your CAPS document on page 54. Okay, now let's look at pre-knowledge. So the pre-knowledge has basically set the foundation for today's lesson. In the 6th grade, you were introduced to the solar system. We also learned about systems for looking into space, as well as systems to explain the moon and Mars. Now let's move on to our baseline assessment. So this is how we're going to do it. I'll read out the questions for you and then give you time to answer the questions. In the meantime, you can send in your responses to our WhatsApp number 064 748 8913. So I'll read out the questions now. The first question reads, give the name of the galaxy in which our solar system is found. The second question is, what does the Milky Way galaxy consist largely of? The third question is, the components of the Milky Way galaxy are held together by blank, so fill in that blank. And then the fourth question is, how far is our sun from the center of the Milky Way galaxy? I'm going to give you 5 minutes to answer these questions. Then after 5 minutes, we'll do the solutions together. So see you after 5 minutes. Welcome back, grade 8. Now let's do the solutions together. Let's read the first question. Give the name of the galaxy in which our solar system is found. Our solar system is found in the Milky Way galaxy. Remember from our previous lesson from last week? Number 2. What does the Milky Way galaxy consist largely of? It consists largely of of stars, gas, and dust. Stars, gas, and dust. And then the components of the Milky Way galaxy are held together by blank. So you are supposed to fill in the blank. They are held together by gravity. The components of the Milky Way galaxy are held together by gravity. And the fourth question is, how far is our sun from the center of the Milky Way galaxy? Our sun is 25,000 light years from the center of the Milky Way galaxy. So now I'm going to give you 2 minutes to quickly copy down the corrections. So see you after 2 minutes. Welcome back, grade 8. I'm sure you are sending in all your responses as well as writing down the corrections. Don't forget to send in your responses to 064-748-8913. And please do mention the name of your school when you send in your responses. So now let's move on to terminology. So these are the terms that we need to know that fall under this topic. So the first term is galaxy. Galaxy. A galaxy is a collection of billions of stars, space dust, and gas held together by gravity. This whole term explains our baseline activity. And what is an astronomer? An astronomer is a scientist who studies stars, planets, and other objects in space. Galileo was an astronomer who invented the telescope. And universe, what does universe mean? Universe means the entire body of all matter and energy that exists in space. All matter and energy that exists in space. And then star, this is a massive ball of burning gas. A massive ball of burning gas. Let's look at the second slide with the next two terms. Constellation. A constellation is a group of stars that, when viewed from Earth, form a pattern in the sky. The ones that are famous are Orion, Ursa Minor, Ursa Major, Taurus, and Gemini. So those are the most famous constellations. And then the next term is Alpha Centauri. Alpha Centauri. Alpha Centauri is the name of the closest easily visible star after the sun. Take note, easily visible star after the sun. So now let's begin our lesson. Our nearest star, which is the subtopic for today. The sun that we see every day is our nearest star. And like all stars, it changes constantly. It looks brighter than other stars because it is very, very close to us. That's the reason why the sun looks brighter than the other stars. Remember when we learned our first lesson? We learned that the sun is a medium-sized star, but it looks very, very bright to us because of the distance we have between us and the sun and the distance that exists between us, the earth, and all the other stars. So the sun produces its own energy. It is capable of producing its own energy. When this energy is released into space, it is in the form of visible light. We can also feel this energy in another form. Do you remember what it is? Yes, that form is heat. So we can receive the energy in the form of visible light and heat energy. So this is what happens when the sun produces its own energy. So the nuclear reaction happening in its core is an ongoing energy releasing process which will last billions of years. Do you remember from our previous lesson how that reaction happens? It's a nuclear reaction between four hydrogen nuclei to form or to produce one helium nucleus. And that is a very powerful reaction. That reaction yields or it produces heat and light energy, the light that we need to survive, as well as the heat to make sure that our water is liquid. Okay, so here is a picture of the sun at closer range from what we usually see it from down here on Earth. So it produces massive amounts of energy, and this energy is what is the driving force behind life on Earth. So the sun is a very, very important star to us, and it is the major star in our solar system. All right, so powerful magnetic fields encircle the sun, which means they are encircling, they are around the sun. These form magnetic storms called sunspots. That's why when astronomers look at the sun, it has some dark spots in it. These dark spots are caused by powerful magnetic fields that encircle the sun and cause what are called sunspots. Sometimes these magnetic fields trigger enormous explosions, and these explosions are called sun flares. And these can be seen using a telescope or from space. The sun flares, and the sun spots peak every 11 years when big masses of hot gas cause further explosion, which can be seen on the surface of the sun. Which means the temperature at the surface of the sun must be very, very hot. Actually, it is 5,500 degrees Celsius. That's how hot the surface of the sun is. It is very, very hot. Can you imagine? Whenever we have a temperature of 30 to 35 degrees Celsius, it feels extremely hot to us. So can you imagine the closer and closer and closer we move towards the sun, how hot it is? So these are the sunspots. These are the sunspots that were taken. This is a picture of the sun taken with a special camera just to show us the sunspots. So these are sunspots that we're talking about. Remember what they are caused by? They are caused by powerful magnetic fields that encircle the sun. And these sunspots and sun flares, they peak every 11 years, producing hot gas that causes further explosion on the sun's surface. So the sun is a very explosive star. So now, what is the distance between the sun and the earth? Do you know what the distance is? Okay, so the average distance between the earth, our planet, and the sun is about 150 kilometers. If you convert it to miles, it is 93 million miles, which means the sun is very, very, very far from us. It is quite a distance between us and the sun. Can you imagine 150 million kilometers away? But we can still feel its heat energy and we can still use its light energy and see during the day. So which means this star is quite a strong star. The explosions that are happening continuously in the sun are quite explosive, enormous nuclear reactions producing heat and light energy in order for us to keep warm, as well to use light energy to produce our food. Ooh, the sun is quite the star, isn't it? Now let's move on to large numbers associated with space and distance. I know I've been talking about millions and billions, but what do these numbers actually look like? Okay, so let's start off with the number in words and in number format. So 1000 in words is written as the letter 1 and the letter 1000. But if we're writing it in number format, it's the number 1 and then 1, 2, 3 zeros. That's 1000. But how do you write 1 million, grade 8? We write the letter 1 followed by million and we read it as 1 million. How then do we write 1 million down? So we write the number 1, the digit 1, and then 1, 2, 3, 4, 5, 6 zeros afterwards. And we read it as 1 million. Next, the next large number is 1 billion. So how do we write 1 billion? We write the digit 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So that is the number format for 1 billion, which is the digit 1 followed by 9 zeros. Okay, then the larger number, 1 trillion. 1 trillion is written as the digit 1 and then followed by numbers as well. We add 3 more zeros there to our 1 billion. Okay, now let's move on to unit conversions. This is a short activity. So now that we know what the different numbers look like, can we convert them? So we're going to convert kilometers to miles. So we're doing kilometer to mile conversions. So we know that 1 kilometer is equal to 0.62 miles. Remember the distance between us and the sun was recorded in kilometers and in miles. So let's do our own conversion. So now we're going to need to convert 150 million kilometers to miles. Remember, we already know how to write 1 million. Let's see if we can write 150 million kilometers. I'm going to give you 2 minutes to do this activity. Then after 2 minutes, we will do the solutions together. See you after 2 minutes. Welcome back, grade 8. I hope you're sending in your responses to our WhatsApp number, which is 064-748-8913. We are looking forward to seeing those responses. Don't forget to mention the name of your school as well so that we can give you some recognition. Now, let's answer the question. Convert 150 kilometers to miles. So this is the information that we have been given. By the question, we know that 1 kilometer is equal to 0.62 miles. So now, how do we do this conversion? First, we need to write down 150 million kilometers in number format. Do you remember how we write a million? We write a million by putting the digit 1 followed by 6 zeros. Same follows for 150 million. You write 150 and then it is followed by 6 zeros. And then it is equal to x miles. X represents our unknown. We don't know how many miles it is, so we need to calculate it. You are free to use your calculators here. So what happens is we cross multiply. We say 150 million multiplied by 0.62. And then that big number is going to give you 93 miles. 93 miles. But how do we read that big number? It's 93,205,676.8356 miles. That's how far we are from the sun. We are very, very far, but sometimes it gets so hot we even get sunburned. Okay, so now let us move on. Grade 8, let's move on. Let's talk about the constellation. Remember, we defined constellation in our terminology slide. So a constellation, we said, is a group of stars that when viewed from Earth form a pattern in the sky. We even gave examples of Taurus and Gemini, just to mention a few constellations, a few famous constellations rather. So if there's a group of stars that when viewed from Earth form a pattern in the sky, remember our Milky Way galaxy is made largely of stars, gas, and dust. So when the stars form a pattern up in the sky, we call it a constellation. We call it a constellation. All right. So the most popular constellation visible in South Africa, the one that we can see, is the Southern Cross or Crux. The Southern Cross or Crux. It is quite a popular one that we can see from all the way down here. So this is what it looks like from the sky, the Southern Cross or Crux, the Southern Cross. So it consists of these stars, 1, 2, 3, and 4, that when you form this pattern, it gives you a cross. Now, next to the Southern Cross, we have 2 stars. We've got the Alpha Centauri and the Proxima. These stars are called the pointers. Why are they called the pointers? They are called the pointers because if you follow this line like that, they point to the Southern Cross. The Southern Cross. And they are the 2 visible pointers that we can also view, that we can also see from Earth. The 2 pointers. They are also stars that are next to the Southern Cross. Now, these stars are very bright and they are found at the bottom left of the Southern Cross towards the cross, and they are called pointers. They are pointing in the direction of the Southern Cross. Now, one of them is called Proxima Centauri. Remember, we saw Alpha Centauri and then we saw Proxima Centauri. Now, let's learn more about this pointer called Proxima Centauri. The Proxima Centauri is quite small. It's smaller and fainter than the Alpha Centauri. And if you look closer, it has a bit of an orange color. It has a bit of an orange color. So it is a small star, quite faint, and it orbits further out. This is the Proxima Centauri. So if you were to look at the Alpha Centauri, the one that is next to it, through a small telescope, instead of one star, you will be able to make up two separate stars called Alpha Centauri A and Alpha Centauri B. And these are next to each other. They are next to each other. And then Proxima, which we have said is the smaller, fainter star, is fainter and much further away from the other two. Which other two are we talking about? Alpha Centauri A and Alpha Centauri B. The other one, so from the other two, you would not see this one with the other two. So this is how the arrangement of the pointers is. We said we have the Proxima Centauri, this one, the faintest star that almost looks orange from afar, which is the Proxima Centauri. And then if you look much closer using a smaller telescope, you will be able to see Alpha Centauri A and Alpha Centauri B. Now, look at how these are arranged. These ones are much closer to each other. 1 and 2 are much, or rather A and B are much closer to each other in comparison to Proxima Centauri. Okay, so if we're to look up in the sky using a telescope. Now let's talk more about the Proxima Centauri. The Proxima Centauri is 40 trillion kilometers away from Earth. That is one long distance. It's actually further from our nearest star. Remember, we are 150 million kilometers from our sun, from the sun, and we are 40 trillion kilometers away from Proxima Centauri. So, besides the sun, Proxima Centauri is actually the closest star there is to the sun. It is the closest star there is to the sun besides the sun. So I've pulled up a picture here so that we can roughly see the distance between us and the sun, us and Proxima Centauri, and Proxima Centauri and the sun. Now, these lines that you see here, these lines represent light years. Remember from our previous lesson, we did talk about light years. That is the distance traveled, or rather the unit traveled by light. Remember, light travels at very, very high speed. Light energy actually has the fastest speed. It has the highest speed. So now, so here is our sun there. I'll mark it with the letter X, and there is us. So this is our solar system, and this is the edge of our solar system. Remember, our solar system has 7 other planets: Mercury, Venus, we've got the Earth, Mars, Jupiter, and the other planets. Now, this is the position of Proxima Centauri, and it is said between Proxima Centauri and the sun, this is quite a distance. Now, so if we're 150 million kilometers and Proxima Centauri is 40 trillion kilometers from us, then if you add the two, that is the distance of Proxima Centauri and the sun. Now, this is us, this is the Earth. So the distance between us and Proxima Centauri is 40 trillion. But because these numbers are so large, we're going to count in light years. So if we look at this band here, this band is at 4 light years. So this is Proxima Centauri. It is 4 light years away from the sun or from our solar system. Now, let's talk about the other two, Alpha Centauri A and Alpha Centauri B, which we'll call Alpha Centauri. Now, the star is called Alpha Centauri, and it is our closest visible star after the sun. So if you're looking at that picture, you could tell from the sizes that Proxima Centauri is very, very small. You'll need a telescope to see it. But the two Alpha Centauri, they are quite visible. It is quite visible, and it is our closest star that is visible. We're talking about visibility here from the sun. So Alpha Centauri is actually part of a triple star system, which is where these stars orbit around together. Do you know them? The triple stars. So we have the two main stars, which is Alpha Centauri A and Alpha Centauri B. So those are the two main stars from the triple star system. And then the third one, we just learnt about it, is Proxima Centauri. Proxima Centauri. Now, they orbit close together and on average about 11 times the Earth distance from each other. That's how fast they orbit. Now I've brought up that picture again, and we need to see the position according to light years, how far these two are. So we said these bands represent light years. So this is 2 light years, 4 light years, and 6 light years. We said Proxima is just there on the line. Proxima Centauri is just there on the line. What about Alpha A and Alpha B? Now, they're in between 4 and 6, but not so far. So it's approximately just over 4 light years. It is just over 4 light years. The actual distance is Alpha Centauri A and Alpha Centauri B are slightly further away. They are 42 trillion kilometers away from us. Our closest star is 609 times further away than Pluto is, the dwarf planet. The dwarf planet is 694 times further than our closest star. Wow, that is quite the distance. So now here's a table just to look at how far in terms of light years these stars are from us, or rather from our sun. Now, so this is the sun. We've marked 0. And these numbers here, 1, 2, 3, 4, represent light years as well as the dates. So the dots are the decimals. Okay, so how many light years away is the Alpha Centauri? So this is Alpha Centauri A and B, and the small one, we call it the Proxima Centauri. Now, so if we count 1 light year, 2 light years, 3 light years, and 4. But they are further away than 4, so let's count 4.1, 4.2, which is Alpha Centauri, 4.3, and 4.3, or rather 4.4 light years away from the sun. Okay, now, so these are very close. A and B are very close. They are very, very close. So we usually count them as one. Those two major twin stars, Alpha Centauri A and Alpha Centauri B, we call them Alpha Centauri. Okay. Now, let's move on to an activity. We have 3 questions here, and then I'm going to give you some time to answer these questions. The first question is, what is nuclear fusion? 2, what is the temperature at the sun's surface? And 3, use the diagram below to measure how many light years the Alpha Centauri is from the sun. So you use this diagram right there to calculate how far Alpha Centauri is away from the sun. I'm going to give you 5 minutes to do this activity. Don't forget to send in your responses to 064 748 8913. So see you after 5 minutes. Welcome back, grade 8. Now we are going to do the solutions together. Let's read the questions again. So the first question was, or read, what is nuclear fusion? What is nuclear fusion? And then the second question read, what is the temperature at the sun's surface? And the third question, we're supposed to use the diagram below to measure how many light years the Alpha Centauri is from the sun. This diagram also came with some information. Let's read the information that the diagram came with. The following map shows the sun in the center with the locations of our closest stars. Each solid ring represents a distance of 2, 4, 6, and 8 light years from the sun. The dotted circle represents the Oort cloud. Now you are supposed to use this information to answer question number 3. Now let's look at the solutions together. The first question read, what is nuclear fusion? What is nuclear fusion? Nuclear fusion, it is a nuclear reaction where 4 hydrogen nuclei are squeezed or fused together to form a new hydrogen nucleus. Remember, this is a very explosive, a very powerful reaction which yields vast amounts of light energy and heat energy that we use here on Earth to sustain life. The second question is, what is the temperature at the sun's surface? What is the temperature at the sun's surface? The temperature is 5,500 degrees Celsius. That's how hot it is at the surface of the sun. And then in the third question, we're supposed to use the diagram below to measure how many light years the Alpha Centauri is from the sun. So there is the diagram there, and we are told that the sun is at the center. There's the sun. It's in the middle of the Oort cloud, and it has the location. The solid rings each represent 2, 4, 6, and 8 light years from the sun, and the dotted circle represents the Oort cloud. Now, let's find Alpha Centauri first. Then we can use the solid rings to approximate the light years. So here we have the sun, and there is Alpha Centauri in yellow. There's Alpha Centauri. Now that we have located it, now let's count and let's see how many light years away we are. So we are at 2, 4. So it is approximately, not exactly, approximately 4 light years away from the sun. 4 light years away from the sun. So that's how far Alpha Centauri is. It's a star, the star Alpha Centauri. I'm going to give you 3 minutes to copy down the corrections. Then after 3 minutes, we will wrap up our lesson. So see you after 3 minutes. Welcome back, grade 8. I'm sure you've had enough time to copy down the corrections and send through your responses to our WhatsApp number. Don't forget to mention the name of your school to our number 064-748-8913. Okay, now let us wrap up our lesson. What did we learn today? What did we learn today, grade 8? So we learned that the sun is the nearest star to the earth. The sun is the nearest star to the earth. It's actually our source of solar energy. It provides with the heat energy to keep our rivers liquid and to keep us warm as well. And it also provides us with light energy in order for us to sustain life. And how does this energy come about? It comes about through reactions in the sun between hydrogen nuclei. This reaction is called a nuclear fusion reaction, where we've got 4 hydrogen nuclei that are squeezed or are fused to create a helium nucleus. And then this reaction causes massive releasing of energy in the form of light, which is our visible light, remember from term 2, as well as heat energy that we solely need on Earth to sustain life. Secondly, we know that the sun supports life on Earth. The plants need it to photosynthesize. They need light from the sun to photosynthesize. And we need different temperatures for different reactions that sustain life to occur here on Earth. So the sun is a very important star. And where do we find the sun? The sun is found in our solar system. And where is our solar system found? It is found in the Milky Way galaxy. Okay, now let's talk about the Alpha Centauri. Now, the Alpha Centauri forms part of a triple star system that is closest to the Earth and the Sun. Do you remember the participants, or rather the members of this triple star system? The members of this triple star system are called the pointers because they point to the Southern Cross constellation. Now, the Southern Cross constellation has those 4 stars that form a pattern that looks like a cross. So now let's go back. Who are the members of the triple star system? So the members of the triple star system, or the stars of the triple star system, it's Alpha Centauri A and Alpha Centauri B, as well as Proxima Centauri, which is very smaller and fainter and maybe quite difficult to see. But Alpha Centauri is very visible. It is very visible from down here on Earth. So that is the triple star system, and they form part of the Southern Cross constellation. Now, Proxima Centauri is the closest star to the sun, which is about 40 trillion kilometers away. Well, it is the closest, but not the closest visible star. Now, it is 40 trillion kilometers away from the Earth, which is quite a massive distance, isn't it? It is very far, and Proxima Centauri forms part of the triple star system, which consists of Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. And these stars are the pointers that make part of the constellation of the Southern Cross constellation. Do you remember what a constellation is? This is where you have a group of stars forming a pattern. They're forming a pattern that we can see from down here on Earth. And there are quite a number of famous constellations. We've got your Ursa Minor, Ursa Major, Orion, Taurus, and Gemini. And now we know the Southern Cross constellation, which can actually be seen all the way from South Africa. Now, Alpha Centauri A and Alpha Centauri B are slightly further away. They are at 42 trillion kilometers from us. That is quite the distance. They are at 42 trillion kilometers away from us. Remember when we're doing those large number conversions, when we're reading the number in words and reading the number in number form, in digit form. So if you can at home write 40 trillion in number form and 42 trillion kilometers in number form. You can also try and convert these distances to miles. You just need to multiply 40 trillion by 0.62 and 42 trillion by 0.62 as well. Then you will get miles. Okay, now this is what we learned today. So what are we doing for our next lesson? So in our next lesson, we're going to be learning about light years, light hours, and light minutes. It is going to be quite an interesting lesson because all along we have been measuring distances in miles, kilometers, and light years, measuring 4.2 light years between the Sun and Alpha Centauri. So we're going to be learning more about light years, light hours, and light minutes. Okay, once you are done watching this lesson, don't forget one important thing. At the end of the lesson, once the lesson has ended, don't forget to click on this special button. This special button is called the complete and continue button. Don't forget to click on that button once you are done watching this lesson. All right, grade 8. Until next time, thank you so much for joining me in today's lesson. Bye-bye.